Okay, here are the notes for today. Picking up in 4.3, example 6, let theta be an acute angle such that the tangent of theta equals 3. Find the values of cotangent theta, secant theta, using trig identities. And I want to pause just a second talking about this acute angle. It also said it in example 5 from yesterday. So if they say it's acute angle, that means it's less than 90. So if you think about where this is going to be in the coordinate plane on the unit circle, it's got to be in this first quadrant here, because those are the angles between 0 and 90 degrees. So we're dealing in the first quadrant, and if you think about positive x, I know we haven't talked too much about it, but all are positive in this quadrant. So we're not going to have any issues with signs. Oh, I'll erase that. So everything's going to be positive. What we're going to do, they want us to use trig identities. First off, tangent of theta equals 3. Well, we have a trig identity that says tangent of theta is 1 over the cotangent of theta. So cotangent of theta, so let me do tangent of theta equals 3. So 1 over cotangent of theta equals 3. Actually, I don't want to do that at all. Tangent of theta is 3. That means the cotangent of theta is 1/3, and we're done. Sorry about that. Reciprocal identity, so we just need the reciprocal. For secant of theta, we're going to think, do I know any trig identities that use tangent and that use secant? Well, one of my Pythagorean identities is tangent squared theta plus 1 is equal to secant squared theta. We're just going to substitute things in. We know tangent of theta is 3, so we can put 3 there like that. Maybe I shouldn't skip that step. Maybe I should rewrite it. I know I put that on the board to be sure that you knew that these two are equivalent to each other. So we've got 1 equals secant theta squared. We know tangent of theta is 3, so we'll just put a 3 here. So that means 3 squared is 9, plus 1 is 10. 10 is secant squared theta. Well, they wanted secant, not secant squared, so we'll take the square root. Anytime you take the square root, you get plus or minus. So secant theta is plus or minus square root of 10. However, we're in this first quadrant where everything is positive. So secant of theta is square root of 10. All right, let's just check that with what we know about triangles. There's theta. If tangent is 3, that's TOA. So make it a fraction. So tangent is opposite over adjacent. Pythagorean theorem says 1 squared plus 3 squared is equal to this hypotenuse squared. 1 is 1, 3 squared is 9, so we get 10 equals h squared. So the square root of 10 is our h. And then let's just check those trig functions and be sure we got the right things. We're pretty confident with that one. A secant is a reciprocal of cosine, so cosine would be adjacent over hypotenuse. So secant would be hypotenuse over adjacent. It works. So it all backs itself up. Okay, example 7 says use trig identities to transform one side of an equation into the other. So that means we're only working on one side of the equation. So we aren't solving, we're just simplifying one side. And I want you to notice what's in parentheses. This 0 less than theta less than pi over 2. So if you think about where that is in the unit circle, we're We're in between 0 and pi over 2. So we're in that first quadrant again, where all are positive. So we have cosine theta times secant theta equals 1. We start with the most complicated side, which is definitely the left. And you think, do I know any trig identities about cosine and secant? Well, after that Kahoot you did, you know you do. I'm going to say that cosine of theta times 1 over cosine of theta is equal to 1, because secant's reciprocal is cosine. And then I'll make that a fraction and cross those out, and you get 1 over 1, which is 1. So we did transform one side of the equation into the other. Okay, in example B, we have secant theta plus tangent theta times secant theta minus tangent theta equal to 1. Definitely left-hand side is most complicated, so that's where we'll start. And when we're multiplying two binomials, we're going to want to FOIL. But look how sneaky. We have conjugates. Well, when you have conjugates, you just do a squared minus b squared. So all we have to do is the secant theta squared minus the tangent theta squared. Okay, and that's equal to 1. Okie dokie. One of our Pythagorean identities, let me rewrite it this way. One of our Pythagorean identities deals with tangent and secant, and it's tangent squared theta plus 1 equals secant squared theta. Can I rewrite this so that I get secant and tangent on one side? So let's think about that. Can't I move this way and move that way? And just think, and if anytime something crosses an equal sign, it changes signs. I like the side that tangent's on. I'm going to move secant over here. And I'm going to move that 1 to the other side. Now when I can compare these, every sign's exactly wrong. I want secant positive, and here we have minus secant. I want tangent positive. I want tangent negative, and here I've got positive tangent. And I want it to equal a positive 1.
I found this on the web.
And it equals a negative 1. So let's just go through and let's multiply this whole equation through by a negative. Definitely legal. Now these two things match, especially if you know commutative property allows you to switch places and still be equal. So we just proved that secant squared theta minus tangent squared theta was equal to 1. So now we have 1 equal to 1. None of this is part of our answer. That's just work that we're doing over to the side. Okay, the last thing I want to talk to you about is on page 278. This is also an old geometry topic. We had to solve right triangle problems, and sometimes they involved angles of elevation. And what I want you to know is that the angle is from the horizontal line up or down. Whoops. Bye. That was Miss Peterson saying bye. So the angle is from the horizontal line up or down. It's not going to let me write the N for down. So if you have to go from this horizontal and our angle swings this way up, that's the angle of elevation. And if you're going from the horizontal and you're swinging that way down, that's the angle of depression. You might remember that from geometry. But horizontal up, angle of elevation, horizontal down, angle of depression. And so example 8 says a surveyor is standing 50 feet from the base of the tree. The surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. How tall is the tree? So in geometry, you might remember if you had me or whoever you had, you might have made a little sketch. And there's the tree, and there's the ground, and here's the surveyor over here. and they are 50 feet from the base of the tree. So that's 50. And it says the angle of elevation to the top of the tree. So that's from the observer up. So the angle of elevation is like this to the top. Make that tree grow a little. The angle of elevation is 71.5 degrees. How tall is the tree? So there is our x, and there's our right angle, and we have a right triangle, and we're just going to do some right triangle trig. I do not have the hypotenuse in this problem. For this angle of elevation, I have the opposite and the adjacent, so I'll be doing tangent. So tangent is 71.5 equals opposite over adjacent. You'll multiply both sides by 50 to get x by itself. And then you'll plug that into the calculator, making sure you're in degree mode, and you should get 149.3. I think you should go ahead and read through example 9 and example 10, just to be sure that you feel comfortable and familiar with those types of right triangle problems that we used to do.